All right, so now we're on section 6.3. Looks a little scary because I wrote the word proofs in there, but it's really not near as bad as what it sounds. So let me get my notes out. Okay. I'm not going to write down the actual theorems. I'll read them off to you. They're in the book if you want to write them down in your notes. I will draw a little picture, though, for each of the theorems that we're going to do. All right. And I don't care about naming the theorems. Depending on what book you have, could name the theorem differently. All right. So some teachers, I've known some geometry teachers that actually make you memorize the theorems. And on the test or a quiz or something, you have to write down word for word what theorem 6-3-1 is. I think that's ridiculous. Okay, because as long as you know what they do, to me, that's the important part. Okay, memorizing, I don't think is that important for this. So I'm not going to make you memorize these theorems, but I want you to know what they do and what they mean. All right, so here's the first theorem. I'm not even going to number them or anything like that. And I'll tell you what, let me draw a little parallelogram, and then I'll just copy and paste it every time. Let's go like 20. All right, so there's my little parallelogram. And let's scooch it right. Oh, come on. Come on, there we go. All right. So here's the first theorem they're going to talk about. Well, let's review quickly. We just finished doing a problem where we talked about these parallelograms, but let me just say it one more time. If you have a parallelogram, okay, so if you know that an object is a parallelogram, so they tell you this is a parallelogram, what do you know? There's a bunch of stuff that you know about the parallelogram. What's the first thing, the definition of a parallelogram? What's true about that parallelogram right there by definition? Right, the opposite sides are parallel. Very good. Okay, that's by definition. Would you agree? All right. If I know that's a parallel, if I told you that that's a parallelogram right there, you know the opposite sides are parallel. What else is true about the opposite sides? They're equal to each other. That's right. That's one of our theorems, okay? If you know that that's a parallelogram, then the opposite sides are equal to each other. Now, if you know this is a parallelogram, what's true about the opposite angles? They're equal to each other, okay? What's another thing we knew about a parallelogram? We knew if we had diagonals, do you remember that? You know, if this is a parallelogram, what would be true about the diagonals? They would bisect each other, okay? And I think that's all the stuff that we know about a parallelogram so far. Would you agree? What if I did not know that that was a parallelogram? Okay, so looking at it, I can't tell you that it's a parallelogram, but, and this is the little twist. You're going to think that this is the same exact stuff that I taught in the last lesson, but it's a little bit different. So this one, you don't know that it's a parallelogram, but you do know some special things about this quadrilateral, okay? Right now, it's just a four-sided figure. Would you agree? Okay? But what if I knew that that and that were equal to each other? Is that enough to say that that's a parallelogram? No, it's not. Because, why is that? Because even though they're parallel, I could have one of these sides like come out like this, and then this side would be like that. Did that make any sense? So watch. I could do this. All right? Now, is that whole thing, forget that part right there, but is that whole thing a parallelogram? No, but these two sides are parallel to each other, right? So just having one side parallel, is that enough to make it a parallelogram? No, it's not. What else do you need? You need the other pair of sides being parallel. Now, again, I didn't tell you that this was a parallelogram, but I did give you this information about a quadrilateral. All right? Now can you say that this thing is a parallelogram? Yes, you can. Okay? So if I have a quadrilateral, I know it's a parallelogram because the opposite sides are what? Parallel. Do you see the difference between today and what we did in the last lesson? This lesson, I don't know it's a parallelogram to begin with. You with me? Okay? But they give you some stuff about this quadrilateral. They tell you that this and this are parallel and these two sides are parallel. If you know that, now what can we say about that quadrilateral? Now we can say it's a parallelogram. Do you see it? Before, we told you that it was a parallelogram. So if it was a parallelogram, what must be true about it? The opposite sides must be parallel. Okay? But today's lesson, we start off just with any four-sided figure, but if I know that the opposite sides are parallel to each other, then I know it's a parallelogram. Okay? That's what this theorem is telling you. It's a subtle difference, but it's a big difference, to tell you the truth, okay? It all depends on what we're given, all right? So the problems that you did on that last homework, they told if it was a parallelogram, they told you right off the bat, this is a parallelogram. Today's lesson, today's homework, what they're going to do is they're going to give you information about that quadrilateral, and they're going to ask you, is that thing a parallelogram or not? See the difference? All right. So, some of you do, some of you don't, but hopefully by the end of this, it'll make more sense. Let's do another theorem. I'll just put it right next to this. Now, right now, do I know that that's a parallelogram? I don't, because I haven't been told, right? Nobody told me that it's a parallelogram. I don't have any information about it. I just know it's a quadrilateral right now. Agreed? Here's one that's a little different from what we did yesterday. They tell you, I'll tell you what, let's do these little markings in a different color just to kind of make them different. They tell you that these two sides are parallel to each other. Again, is that enough to say that that's a parallelogram? No, it's not. But here's something that's different than what we did the other day. Okay, here's what they tell you. Everybody watching? Everybody's watching, right? Okay. Now they tell you that this side and this side are equal to each other. This theorem, which we haven't proven, and we probably won't prove this theorem, okay, but just given those two things, that's enough to say that this thing is a what? Parallelogram, okay? So if I told you that one pair of opposite sides were both parallel to each other and equal to each other, congruent to each other, if I told you that, that's enough to say that these are parallelograms. It's got to be the same two sides, though, okay? Correct. Well, I mean, it would be possible, but it's not always true that it would be a parallelogram. He said if these two sides were parallel and these two sides were equal, would that make it a parallelogram? No, not necessarily true, okay? Because, again, remember I made it into a trapezoid, okay? If this, I could make this side of the trapezoid and this side of the trapezoid equal to each other, and they're parallel, but that doesn't mean it's a parallelogram. Everybody got it? All right. So what do we know so far? We know if you have a quadrilateral, and if they tell you that both opposite sides are parallel, then it's a parallelogram. If they give you a quadrilateral, and they tell you one pair of opposite sides are both parallel and equal to each other, then it's a what? Parallelogram. Okay? It all depends on the stuff that they give you. Let's do another one. We have two more to do. I think, yep, two more. So now, and let's go in yellow. Come on, there we go. So now, if they told you this, if they told you that this angle, now right now, on this quadrilateral, do we know that it's a parallelogram yet? No, they haven't told us anything about it, so I have no idea if it's a parallelogram. They didn't tell us it was a parallelogram. They didn't give us any information. So right now, as it sits, I have no idea if it's a parallelogram. Right? It may look like it, but it may be off just a little bit, right? So anyway, what if I told you that this angle and this angle are equal? Is that enough to say that this is a parallelogram? It's not. Okay, I got to have more than that. I got to have both pairs of opposite angles congruent or equal to each other. If I have this, so I start off not knowing that it's a parallelogram, but if they tell me that the opposite angles are equal to each other, then guess what's true about this thing? Then it's a parallelogram. So you don't have to know anything about the angles over here. Because this is enough. Okay? Just knowing that these two are parallel. Now, there is a proof for this. We're not going to go through the proof. It's a good question. I'm glad you asked. Why not? But I think they might leave this proof for a question in the homeworks. But we're not really doing official proofs in here. Right today, and I've said this before, that you shouldn't just take my word for it. But today, I changed my mind just because it's a little involved. If I could grab this thing. Come on. There we go. That's hard. All right. Let's do one more. Let me change the color. There we go. All right. Let's do one more. What are these things right here I'm drawing? What is it? A diagonal. Very good. Okay, this is called a diagonal. All right. Now, again, right now, I don't know anything about this. I just drew the diagonals. I didn't say anything about any of them are equal to each other or anything like that. Agreed? All right, so right now, I don't know that this is a parallelogram. But if I was told, right, if they told me that this little part and this little part were equal, that's not enough right now. But if they also told me that this little part and this little part were equal, that's enough. So what's true about the diagonals? The diagonals bisected each other, right? So what does that make this quadrilateral now? It makes it into a parallelogram. You see the difference between 6-2 and 6-3? This one, you start off not knowing it's a parallelogram. They tell you stuff about it, and then you can look at it and say, yes, that's a parallelogram. Or, no, it's not a parallelogram. All right? They might give you some stuff where it's not a parallelogram. For instance, this next example. Let's do this. Let's rotate it a little bit like that. Now, it looks like a parallelogram, doesn't it? I just twisted it a little bit. Okay, but I'll tell you what, we can make this a little bit bigger, about right there. Let's put some stuff in here. What if I said that this, let's change colors again. We'll stick with yellow. What if I told you that this and this were equal, and I told you that this was 108 degrees and this was 72 degrees? That's all I told you. Could you tell me if that's a parallelogram or not? Well, we do know we have two opposite sides are equal to each other, so that's good. What about the 72 and 108? Why in the world did I give you those numbers? They add up to 180, so that means that, let's put some letters in here. This is D, E, F, and G. All right? So tell me something. If these two, where's the transversal? So this angle and this angle right here. They're not equal to each other, okay, but they are supplementary. Which ones would be parallel and which ones would be the transversal? What would be the transversal? G to E? No, there's no line here. Okay, which line is shared by both of these angles right here? GF. Everybody see that? So, what does that mean about D, G, and EF then? They're parallel to each other. That's right, okay? Because these are consecutive angles, right? Consecutive interior angles. If the consecutive interior angles are supplementary, that means that this and this are parallel. Now, tell me something about this thing. Is it a parallelogram? Why? Because one pair of sides are both what? Parallel and equal, okay? And that was our second theorem, right? That was the second theorem that we did. So, is this a parallelogram? Yes. Okay, that's the question. Okay, is it a parallelogram? And it is. Okay, why? Because DG and EF are parallel, DG and EF are equal to each other. That makes it, because of that second theorem, that makes it a parallelogram. Make sense? Let's do a couple more of these. There we go. Okay. Look at this. Now, at first glance, what does this look like? Looks like a rectangle, but can I just assume that that's a rectangle? Not necessarily. J. Okay, here's the information they give you about this. You don't know anything. I mean, that looks like a right angle, but you don't know that's a right angle. Okay, but watch this. What if this and this were equal to each other, and this one and this one were equal to each other? Is that enough information to say that that's a parallelogram?
Yes. No. Yes.
Whatever pleases me. It pleases me. that you stick with an answer.
Wait, no. Wait, yes, it is. No, it's not. No, it's not. They're not opposite. The angles are opposite. So.
That's right. The opposite angles have to be equal to each other, not the consecutive angles, okay? Because what does that mean? Basically, what this basically means is just that this and this are parallel to each other, okay? That's all that means, all right? So, because if you look at it, I could have taken this angle and stretched it out. I could have or not this angle, but I could have taken this side and stretched it, this side stretched it, connected from here to here, here to here. All this stuff would be true, but that would not be a parallelogram, would it? Okay, it would have been a trapezoid, okay? So, is this a parallelogram just with this information that's given? No, it's not, okay? Let's do another one. No, I'm not going to do let's do another one. What if, I'll tell you what, I'm going to use the same picture. Let me just get rid of all that stuff right there. What if they told you that this was a right angle and this was a right angle? Does that mean that this is a parallelogram? Does it? How do you know? Why does that have to be a right angle? Because watch. Again, I could have taken KL. I could have stretched it out like this. Do you see that? Watch. I could have taken KL, stretched it out like that. Agreed? And then I could have taken this like that. Is that whole thing a parallelogram? No, but this is still a right angle, and that's still a right angle. But I could have made something that's not a parallelogram having two right angles. Would you agree? Yeah. So what must be true if this is a right angle? Then if this was a right angle, then that would be a right angle, and then it would be a parallelogram. So is that original one, does it have to be a parallelogram? No, it doesn't. We skipped example 2, so let me tell you this. I recommend going through example 2 before you do your homework. Look at it. They kind of give you explanations. It's pretty much the kind of stuff that we've done earlier, so it shouldn't be that bad. So your homework is section 6.3. Yeah, and your homework from last night, I'll take it up here. So put it right here on the corner of the desk. So it's page 267. Oops. It's page 267, and it's 18 to 25. That's on your little lesson plan sheet I gave you anyway, but there it is for you two people who need to see what our homeworks are. If you go to RenWeb, I've been putting the lesson plans on RenWeb as well, okay? So if you lose your sheet and you don't remember, if you're absent, you could always go to RenWeb and look at what the assignments are.